Chapter 5 discusses the idea of two-way tables, and it discusses the definition of two-way tables as the comparison of two different categorical variables. Here I show category A and B versus category 1, 2, and 3. This could be small, medium, and large, and this could be say packed in a can, and this is packed in a box. And then they give you some numbers here, like maybe 12 here and 5 here and 7 here and 5, 3, and 8. This is your data. Now, one of the first things they talk to you about in taking a two-way table is to add up all of these rows and all of these columns. And so we had 17, and 7 is 24, and 5 and 3 is 8, and 8 is 16. And adding down, we get 17 here, we get 8 here, and we get 15 here. And then this final box over here is a sum of those margins, and both these should add up to the same amount. Looks like this adds up to 40 here, and we're going across here. 18, 7 is 25, and 15 is 40. Nice, 40. So that's just basically the housekeeping of a two-way variable. Now, these are not measurements. We're not comparing measurements. We're comparing some kind of category. Small, medium, large, cold and hot, blue and red, and we're just comparing these two things on this table. Now, it could be A and B could be some kind of treatment here, and then this category could be age groups, child, teen, and adult, something like that. So they're not measurements, they're categories of information. That's one of the key things about the two-way table that we need to look at. Now, any of these data points down here on the outside are called marginal. Those are marginal distributions. So if I were looking at the marginal distribution of treatment A, I would look at and compare this row of data, or the total of that data, versus the overall total of data points taken. So the marginal distribution of treatment A would be 24 over 40. And when we talk about distributions, we usually express them in terms of a percent. You could also just leave it as a fraction, 24 over 40. If I were looking at the marginal distribution of children, I'd say 17 out of 40. I come down the column, I take the column total, and I compare it to the overall total. So when I use the term marginal distribution, I'm talking about these numbers out here on the edge, or the margin. Now, your textbook also refers to the conditional distribution. The conditional distribution then deals with the numbers that are inside. Let's say that we were looking for the conditional distribution of an outcome. And we'll say, the outcomes were okay, damaged, and broken, completely broken. So in terms of this kind of table, the outcome would be it's okay, it's a little bit damaged, or it's broken completely. So we say the conditional distribution of the outcomes, given what? Given this kind of packaging A, or given packaging B. So we're going to look at the data here, given that I used packaging A. And so my given treatment, I then look at the given part here, given treatment A, we'll say. So I'll take treatment A, that's where I start, and I look at this row. I'm going to use this as my total, and I'm going to compare the number of outcomes that were okay to the total of 24 in the packaging style A, or treatment A, or packaging, however you want to call that. So the book uses this: find the conditional distribution of something given something. Well, the given is where you want to start. Given packaging B style, we'll say, what is the outcome? So then I'll start here with this row, and I'll say, okay, given that I'm using packaging B, what's the conditional distribution of broken items? And then I would take A divided by this total out here, 16. So the conditional distributions are looking at the data point versus the marginal number, the total in that particular thing. So the given puts you in the column or the row. If I said given the outcome, or if I said find the distribution of packaging versus given that the outcome was okay. So I take my outcome of okay, which is this row here, and I'm going to use this total, and I'm going to say, okay, given packaging A, what's the conditional distribution given that the outcome is okay? So I'll take 12 out of 17. So again, my given determines what column or row I'm going to use. In this case, I'm going to use the outcome okay. I'm going to use this column, and then I'm going to look at the data in that relative to the total of that column. Now there's also a little subtle statement they make. They might say the conditional distribution of something, of X, and they might use the term comma among males, something like that. What they're saying with this among males, they're saying given. This is my given. And then this is the conditional that I'm going to use. So if one of these were, if this were male and female, among the males, then that would say, okay, my males are here, my females are here. Among the males, then this is the row I'm going to deal with. So they're very subtle about some of their question statements. And so if they say among or given, that's your starting point, and then the condition is the data value within that given row or column. Alright, so that's just a little lead in, and we're going to pause here for a minute while I set up the first problem. So in problem 1, we're given a little table with HIV treatment or something, and we're given several treatments, and we're given a fact that there is either a response, an immune response, or there is no response. And you see this data, and the first question says, well, how many people does the data describe? In this case, what we're looking for is the total of this amount of data here. So we could add the columns down. There's 16 coming down this way, 8 and 3, it says 24 there, for a total of 40 data points, or 40 people who were involved in this study. Question B says, how many people received intramuscular? In that case, we're going to look at the intramuscular row, and we're going to come across, and we're going to take the total of that row, and the total of that row is 8. So 8 people received the treatment in intramuscular, via intramuscular. Now it then asks for marginal distribution for the immune response. This, it's not really clear, but I think what they're asking for is which one had a positive immune response. So what we're looking for is this row here, which then turns out to be 16 total. And then we're looking for a marginal distribution, so we're going to take this marginal value relative to the total, so that will be 16 out of 40. And then you'll just change that to a percent, and that will be your marginal distribution for the immune response. The best I could do was that this was immune and this was no immune, or not immune, there was no response, or there was no immune response. Again, the question is worded kind of iffy. So let's go look at problem 2. In problem 2, we're given a table regarding prairie dogs and their response. We were told that one of the responses we were looking for was a call that they made of predators in the area, and the other response was they made no call at all. And then we had another category that said the predator was either near or far from the prairie dog in terms of its response. Well, the first thing we do is we add up all of our rows and all of our columns to get our marginal amounts, and we end up with a grand total of 242 data points within our table. So the first question was, well, how many data points, or how many prairie dogs did we count? And that is a total of 242. Then it asked how many near did we get. So the near column going across, we had a total of 109 data points relative to the near proximity. Then they asked for the marginal distribution of calls. The marginal distribution of calls. Well, these are calls. We have a call or a no call. So we're talking about these two columns here. And they're actually asking for two different answers here. They're asking for the marginal distribution of calls and the marginal distribution of no calls. Or at least that's the assumption that I make. If they had said that a little differently, I might have said, okay, the marginal distance of a prairie dog call. So we would have had 84 out of 242, and if we took the marginal distribution of no calls, that would be 158 out of 242. Expressing those in percents, this is 35% approximately, and this 65% approximately. So based on this data, the marginal distribution of calls that were made, 35% of the prairie dogs made a call, 65% of them made no call. Now, if you asked for a conditional distribution, or you wanted to analyze this and say, well, what is the likelihood based on the nearness or proximity? Given some proximity, either near or far, what would be the marginal distribution of a prairie dog making a call given that the predator was still far away? Well, then we'll take the given here and we'll look at the far column, and we'll come over here and we'll use this total, and we'll use the fact that they made a call and the predator was far away. So this would be 55 out of 133. If I made the marginal distribution, conditional distribution. If I'm using the data inside, I'm making a conditional distribution estimate. If I made the conditional distribution of the prairie dog giving no call, I would then take this 78 divided by 133. So in working your data, that's what you want to look at. Is it a conditional distribution? Then you're going to use the data inside relative to the margin total. And then you're going to have to figure out, well, given what? Given far, given near, or whatever the statement is. Okay, so let's go on to the next problem. Okay, in problem number 4, we're given a table where they tested cranberry juice, some lactose drink, and then subject neither of the drink was given. And they had a total of 149 subjects they tested. And there was a condition where there was a reoccurrence of the problem, and then there was a group that had no reoccurrence of the problem.